Good morning, 8th grade. I hope you had a good day yesterday doing that science test and getting all those problems correct. And so this morning you're ready to start in on math. I think we're lesson, what, 13? Get my book here so I can see. Yes, lesson 13. And you're talking about the volume of irregular solids. You're not learning anything new. You're not doing anything different than what you haven't done before, except one thing: you have to add them together. So I did an example problem here. It's similar to the first problem there on the bottom of page 52, but it's a little bit different. I made a bigger one. This was like a big bin that farmers use to store grain in, and like if they want to let me see, load out a semi quick, they'll put grain in here and then they'll pull a semi underneath here and let the grain Is that right, Seth? You know how that works, right? Well, I didn't have a semi to put underneath here, but I did have a car. So right now in this scenario, we're just going to fill the trunk of the car, okay? So it's not going to take much grain. Seth, you have to be real quick on the switch, open the gate and close it quick, because we just want the trunk of the car full. That's all we need of grain. So anyhow, this here hopper bin, or I don't know what you call it, this grain bin, it's got a cone at the bottom and it's got a bin on top. And the radius is 10 feet, okay? The height of this part is 20 feet. And then we got the cone below here, and the cone from here down that comes to a peak is 15 feet. And you know why they got the cone on there for? Well, that's so you don't have to go up there. See, they could have made this bin come straight right here, right? Could have just made it straight. But then you'd have to go up there and shovel out the corn, out of the corners. So they made a cone. Oh, someone was brilliant. It was like saving the farmer's back. Yeah. Okay, so what we have to do is, you know how to figure a cylinder. You got the 10 foot, I'll talk about that here in just a moment. You figure the cylinder, and then you figure the cone. And you can actually, if you're real sharp on this and you're real careful, you can actually do some of this figuring, transfer it over. And I'll show you how to do that here just in a moment. So the first thing that I did, for A, first thing I did, I got my formula, and we are going to figure the cone first. So it's 1/3 BH is your formula. If you write it out, it looks like this: 1/3 pi radius squared height. So I just figured those steps. So I said, well, this is 10, so that's the same here. My sides are straight. So this radius here for this one is the radius here. Same. Okay? So I went 10 times 10. So I actually did my radius first. 10 times 10, and then I figured pi. So that came up to 100. And you know pi is 314. Now you use your calculator. Don't waste your brain power. Yeah, well, no, it's all right to use your brain. 314 times 100 is 314. Okay? So I've got my radius pi squared. Now I get my height. And that from the peak of this cone to up to here is 15 feet. So I multiplied 15 times 314, and it came up to 4,710. Now, you see, it's a cone, so you have to divide it by 3 or multiply it by 1/3, however you want to. So I divided it by 3, and I came up with 1,570 feet cubed. Okay? This is an answer that I will need for the cone. That's how many square feet, no, cubic feet in the cone. Now just hang on to that answer. And now we're going to go figure the cylinder. It's 10 by 20. Okay, I moved right over here to B. Here's B. And I have a base and a height. And you know that the base is pi radius squared h. It's almost the same as the cylinder, pi radius squared h, except the 1/3. So you just drop off the 1/3, pi radius squared h. So I use these same figures. I figured this thing exactly. I used my pi radius squared. I figured that here. I just moved that straight over. That was 314. I moved it over here. So I saved brain power again. And now I had to multiply it times 20. So 314 times 20 is 6,280. Should have maybe made a comma there. 6,000, and this was 15,000. Now, this is where you're maybe doing something a little bit more, but it's real simple. You need to add the cone and the cylinder together. So my cone was 1570, and my cylinder was this here. So I move right over. Let me turn this a little bit so you can see. I moved right over 1570 and 6280. These numbers here, I added them up and I come to 7,850. Now in the book, it will tell you that 1 cubic foot equals 0.8 bushel. Now, I want to know how many bushels in there. I want to know how many semi-loads I can put in there. So I go 0.8 times my 7850. So that's my fourth step, D step. I went 0.8 times 7850 and I come up with 6,280. Now that's the same numbers I come up here. I guess that's correct. I never did the math to figure that out. I just all of a sudden noticed that was the same. So that means I could put 6,280 bushel. And what, Seth? Can you put 1,000 bushel on a semi? You can put 1,000 bushel on a semi. We'd have 6 semi loads there. If we had the bin full, you could load out 6 semis and go to town. Yeah, I will. You look at the next problem on the example at the top of the page. I will help you do the first one. Okay. Not all of them are going to be rectangular or circles or cones. There'll be different shapes. So the first one, number 1, it says, Bill helped Gail's father calculate the volume of a second floor bedroom in preparation for installing a ventilation fan. The room is 14 feet long with a cross section as illustrated. Okay, so it's not a 14-foot square square room. So if you look at the first one, it says find the area of 2 trapezoids. So that's what I put up there. If you don't know what the area is of a square, a trapezoid, whatever, you look in your book, you look on that little math paper. I don't know if you still got that little math facts, I'm not sure what it's called. You look somewhere and find it. But the area of a trapezoid is 1/2 base 1 plus base 2. So in this room we have a slope that looks like this. You know how this is. You've seen upstairs bedrooms already with a slope in at the top that is called room and attic. I'm not sure what you call it. But he has a 4-foot, this is 4-foot wall, and then right here he has a 7-foot wall. And he's got 3 foot here. Of course, he got the 7-foot right here, and he got 3 foot over here, and then in the middle we have 6 foot. So this part down here is 3 foot, 6 foot, 3 foot. All right. Now the trapezoid that he's talking about. He says the way you figure this here, this middle would be simple to figure. Right here, you have 6 foot wide, 7 foot tall. Now I can just about do that in my head, but hang on. We got to get this first one here. We got to get this trapezoid. This is a trapezoid right here. It's 4 and 7, so we have 2 different legs. I wish if it would be square, you could figure like a rectangular, but it's not. So we have to go base 1, B1, so that's 4. B2, we're going to say 7, or you could flip them. It doesn't matter. You have to add those 2 together. So 7 plus 4 is, you don't know? Yeah, 11. 7 plus 4 is 11. Let's do this here. We get this down here. That's 11. Now, it doesn't matter. You can go up times half, which would be 5.5. I would rather go, see, here's 3. We got 7 and 4. So how wide is the height? What's the height? I guess we're going to lay this trapezoid down. So the height is 3. So that would make me 33, right? 3 times 11 is 33. And it's half of that 33. There we go again. So it's going to equal 16.5. That's half. I went half of 33. Okay, so did you follow me along with each step here? Now I got one side here that's 16.5, but I got another side that's exactly the same. So do you want to refigure this and add them together, or do you want to just go times 2? Well, here I just got done dividing 33, so I can go 2 times 15, or 2 times 16, that comes back to 33 again. Wow. You see, sometimes you can just do a little thinking, and you can save a lot of figuring. So my first answer, find the area of the 2 trapezoids, 33. That's your A's answer. Anybody got a question on how we got A's answer? We figured these two. How did I know to do that? I just used common sense, okay? They helped you here. They said figure trapezoid. Sometimes you'll just have to think. Maybe you want to figure the square first. I wanted to because that was the easiest. But you just have to, when these type projects say, how can I do this? So let's go to B. Find the area of the rectangular. Now the rectangular part, this part right here. It's 6 foot from here to here, and it's 7 foot from here to here. So 6 times 7, should I do that right up here? 6 times, whoa, here. Yeah, I'm going to do that. 6 times 7 equals 42. Can't beat that, can you? So we got 33, the first answer. B's answer is 42. Did you follow me? Now, I've got everything figured, except how long is it? Okay, now I got to stop, and for C, it says find the area of the base, one end and wall of the room. So what that's saying, the next step is I need to find the base of this whole end wall. Well, you know what that means? I got my 33, and I got my 42 for number C. I've got to add them together. Now, how did I know to add those together? Well, how was I going to find the whole end wall? I have 33, these two, and I had 42. So add, just think, I guess is what I'm saying. 5, 75, 3, 4, 5, yeah, 5, and 4 and 3 is 7, 75. Okay, I got 75, it's going to be feet squared, but we'll just let that there. That's my C's answer. Now for D, it says find the volume of the room. Now how do I find the volume? I got the one in. How do I find the volume? Is there something telling you? Are you thinking volume? Base times height. Yes. Okay, what's the height of the room? Well, let's pretend like we set the room on in, and the base was 75. What's the length? Oh, look at the picture. Oh yeah. Someone tell me? 14. You're right. So now I've got 75, and I have to multiply it times 14. Oh, that's a tough one. You help me out. Use your calculator. And that is a total of feet cubed. Anybody got the answer there? 14 times 75. Push it in quick. That will be D's answer. Okay, this is C and this is D. Not all of them will have 4 steps maybe. Happen to be the 2 examples I did. A lot of them will have 3 or 4. Let's see, this was A's answer here, and this was B's answer here. Yeah, so I got A, B, A's actually down here at 33. Anybody got this answer yet? Come on. Quick. Who's first? Oh, yes, thank you. 1,050 cubic feet. Now, you ready to turn the page to number 2? And again, this guy was buying a fuel tank. It was going to fit underneath the toolbox in his pickup. It's an L-shaped tank. You've seen those, right? Well, boys have seen those. Yeah, boys know about these. Girls, I don't know if they know anything about fuel tanks or not. They're going to learn something, though. They're going to learn about them. So you're going to find the volume of the tank. And so just take a look at it. You got a piece here. Find the volume of this. Find the volume of this. Now, be careful and don't double figure the corner. Don't double figure that one. So if I was to do the first part of the top one, I would start out as 48, 6 inches by 10 inches. That would find the top part. and I would multiply those together, and then I'd find the volume of the bottom tank. The bottom part is 4 inches, it's 22 inches, and it's still 48 inches long. So I'd find that there, multiply those together. And I'm getting pretty close to telling you the answer, but when you got those multiplied together, guess what? Add the two together. Add the top part of the tank and the bottom part of the tank together. And then the last answer is, who can tell me how many square inches in 1 gallon? Yes, remember, it's the same as a highway, and it's not Highway 50, okay? It's the same number as a highway that goes through Lagodi. It's, yeah, come on, yeah, you're thinking, yeah, what's that number of that highway that goes through Lagodi? How many cubic feet in 1 gallon of water? 231. You got it. You have fun doing your lesson. See you.